Here we are looking at fundamental theorem of algebra, and I'm going to divide this lesson into 3 parts. That way the videos are manageable. So the first one is to use the fundamental theorem of algebra to write equations. And how am I going to do that? To be able to do that, I'm going to start by reviewing some few concepts from Algebra 2. And here you can see a real number r is a root of the polynomial equation p of x is equal to 0. If that is the case, p of r, that means if you substitute r into the equation, you get 0. It also means that r is the next intercept of the graph of p of x. It also means that x minus r is a factor of p of x. And then when you divide the rule for p of x by x minus r, the remainder is 0. And then r is a 0 of p of x. Okay, so here, write the simplest polynomial function with the given zeros. So how are we going to do that? So I'm going to write p of x. Remember, I'm using this first step. It says then x minus r is a factor of px. So if I'm given these zeros, then x minus negative 2 is a factor, x minus 2 is a factor, x minus 4 is a factor, and I can simplify this. This is x plus 2 is a factor, x minus 2 is a factor, x minus 4 is a factor. And now all I need to do is to multiply the first two binomials. So what do I get? It's a difference of two squares, x squared minus 4, and then I have x minus 4. Then I just need to go to the next step, and I can show you here an easy way to do that. X squared minus 4, and then we have x minus 4, so we get x cubed minus 4x. This is minus 4x squared, and this is 16. So we highlight those. Let me just highlight those ones because they are the ones I'm going to write, because that's my final answer. So it's going to be x cubed minus 4x squared minus 4x plus 16 is equals to p of x. So here, that's how you can write the equation given zeros. In this lesson, we are going to see how we can use the fundamental theorem of algebra to find zeros. I want you to notice this equation, which is the one we came up in the first part of the video, and we had 3 zeros. And note the number of zeros are 3, which corresponds to the degree. And how is this helpful? It's helpful because every polynomial function of which is equal to whose degree is n or more than whose degree n is greater or equal to 1 has at least 1 0. The 0 may be a complex number, or it may be the 0 may be a complex number. And let's look at an example here. So using this theorem, you can write any polynomial function in factor form. Then to find all the roots, you can use a combination of rational root theorem and irrational root theorem and methods of finding complex roots, for example the quadratic formula. One theorem we have mentioned is the rational root theorem, and we use the rational root theorem to find all the possible roots of an equation. Let me give you an example here. So if I have the same equation, and let me write it here, p of x is equals to x cubed minus 4x squared minus 4x plus 16 is equals to 0. If you are told to solve this equation, you can be able to get all the zeros. You already know them. But what about if you are told to list all the possible number of zeros? Because that would be the first step to solving this equation. So how I would do that is identifying the P and Q. That's my first step. And to identify the P is this number, which is 16, and Q is the coefficient of the highest degree variable. In this case is 1. And then the next step would be to write all the factors of 16 over all the factors of 1, and when you do all that, this will give you a listing of all the possible zeros. And we are going to, let's look at an example on the next. So if I have this equation here, I'm told to list all the possible zeros. So the first thing, the coefficient, we get the coefficients. And what are the coefficients? The constant term, which is the P, and the leading coefficient, Q. So those are the P and Q. Then we find all the factors of P and all the factors of Q. And then when we do that, we are going to get all the possible zeros. For example, here we have 2. So the factors of 2 are, are 1 and 2. The factors of 15 are, so this is 2, 1, 3, 5, and 15. But don't forget we have the plus or minus of all those. So that's why here you see the factors of 1 and factors of 2. And then to get the individual factors, you take the numerator. So 1 and 2, you divide by 1. 1 and 2, we divide by 3. 1 and 2, we divide by 5. And that's how we get all this list. And from what you see right here, there are 16 possible rational zeros. But the actual number is 1, 2, 3. Because we can see the degree is 3. Let's do an example here. We are told to find all the possible rational zeros, and that's what I want this video to be about, writing all the possible zeros. So here we're going to, let's list all the possible zeros. So we identify the P, which is 24. We identify the Q, which is 1. So we find the factors of 24 over factors of 1. So we're going to write them here. The factors of 24 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24, and then we are dividing by plus or minus 1. And what do we get when we do this? When we divide by 1, they remain the same. So the factors are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. So that is the list of all the possible factors. And you can see 1, 2, 3, 4, 5, 6, 7, 8. So there are 16 of them. So that's how to find the list of all the possible factors. Not the possible factors, but list of all the possible roots. On this part of the video, we are going to find all zeros of a polynomial. So if I'm given an example here, I'm told solve by finding all the roots. So you can see the polynomial is of degree 4. So I know there are exactly 4 roots of the equation. Then I'm not going to use the rational root theorem to identify the rational roots. So my step 1 is to identify the P and Q, and I have them there. The next step is to write all the factors of 36, which are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, and plus or minus 36. So I'm dividing by plus or minus 1 because factors of 1 are plus or minus 1. So those are the possible zeros. But I know only I have 4 zeros, 4 roots. So what do I need to do next? So here I'm going to graph this equation so that I can find the real roots. So graphing helps me to find the real roots. The real roots are given by the x-intercepts. So I have the real roots, which are -1 and 4. And what do I have? I have 1, -3, the previous page, -20. The last one is what we are doing. So this is export. So now I'm going to test all the possible roots. I'm going to start with -1. Remember, -1 is on the list of all the possible zeros. So I'm going to go back and 5. So I have 1, -3, 5. I'm just and then the last one is 6. And to test -1, I'm going to use synthetic division. So this -1 times, so I bring 1 down, so 1 times -1, get -1. So remember we are going to add, so this is -4, so that becomes +4, so that becomes 9. So this is -9, so this is -36. When I multiply, I get +36, so I get 0. So that means that x plus 1 is a factor. And I'm going to write everything. See, all these are coefficients. So I go 1 degree down. So this is x to power. Remember here, so 1 degree down is going to be x power 3 minus 3x squared plus 5x. Oh, I made a mistake because I copied the wrong coefficients. Minus 4x squared plus 9x minus 36 is equals to 0. Note that, see, I got one of the factors, so I'm now going to move on and test one of the other zeros. Next step, I'm going to take what I wrote on the other side and I'm going to test 4. So let me write, use synthetic division. So I have 1, -4, 9, -36. Those are the coefficients I have from up here. And then I'm testing 4. So 1 comes down. So this is 4 so this becomes 0. So 4 times 0 is 0, so I have 9, so this becomes 36, so this becomes 0. So what do I have now? So that means x minus 4 is a factor. So what do I have? I have x minus 1, which I already tested, x minus 4, and then I have, remember this, so I need to write this as an equation, so it's going to be x squared minus 9 plus 9 is equals to 0. So that's what I have. Now next step, so I'm going to solve x squared plus 9 is equals to 0 so that I can get all the other roots. So that means x squared is equals to minus 9, then I get the square root of both sides, and not forget plus or minus, which is going to be plus or minus 3i. Remember, square root of a negative is I, so square root of 9 is 3, negative is I, so the fully factored form of the equation is going to be x minus 1, x minus 4, and the other one is x minus 3i and x plus 3i is equals to 0. That's the fully factored form, and the solutions are 1, negative 4, 3i, and negative 3i. And see, this corresponds to the degree 1, 2, 3, 4. So we have 4 solutions. So that's how we can be able to solve that polynomial. Okay, let's move on. So here, our next example here, we are going to writing a polynomial function with complex zeros. So these are the zeros we are given. So we are given 2 plus 1, and we know 2 plus I does not come by itself, so we have another one. Remember, complex roots come in pairs, so we have 2 minus I, and then we also have square root of 3, negative square root of 3, and we also have 1. And you can see here, we can see this statement here which says, it says by the let me just move it. We can read it by the rational root theorem and the complex conjugate theorem. The irrational and complex roots come in conjugate pairs. So these are the roots we have. There are 5 of them. So now the next step is to write out. So write the equation in factored form. So I take the first one, x minus 2 plus I, x minus 2 minus I, x minus square root of 3, x minus square root of 3, and x minus square root of 3, x minus square root of 3. So when we multiply them, we multiply, and this is what we are going to get. This will be the final equation.